First of all, let me thank you all that you attend in this very hot evening. At least it's hot in something. So, this is the last. This is the last lecture for this year, for this semester, and we are very honored to have Quentin with us to give us this view for central Crete through the use of geospatial techniques. I have to remind you that since like 2 years now, we are running this series. It's called Mapping the Past. That we invite people from different backgrounds, from PhD students to full-time professors, to speak about mapping, about geospatial techniques. And the feedback we have up to this point gives us, the courage to continue. So we have a new round for next year. Everything is, almost everything is uploaded in our YouTube channel, and my colleagues will give you the link so you can later visit and watch the previous lectures. For the moment, I will give a microphone, the podium, to my colleague, Meliana Karta, that she will introduce Quentin. After this small introduction, Quentin, you're ready to start. So, and you speak about the GIS in Central Crete. So the mic goes to Meliana.
Hello, everyone, from my side. Thank you once again all for joining us in our last lecture. Well, it is our great pleasure to introduce today's speaker, Quentin Drillat, an experienced researcher specializing in archaeological GIS, digital fieldwork documentation, and landscape archaeology. Quentin is currently pursuing his PhD in archaeology at Ghent University at Belgium, where his research focuses on the spatial organization, fragmentation, and development of city-states in central Crete from the late Minoan II to the Hellenistic period, under the supervision of Professor Roald Docter. His work combines archaeological theory with advanced digital methodologies to explore the dynamics of ancient Cretan societies. He holds both a bachelor and a master's degree in archaeology and landscape archaeology from the University of Strasbourg, where his master's thesis examined land use and settlement patterns in the Anapodaris catchment in Crete, covering a long chronological span from the late Minoan II to the Roman period. In parallel with his academic research, Quentin has built extensive field and professional experience. He currently serves as GIS manager at EVEHA International, working on archaeological projects in both France and Saudi Arabia, and as we found out today, the Caribbean. His previous position include research engineer in geomatics at Le Mans Université, as well as assistant in Greek archaeology at Ghent University, where he was actively involved in the Thorikos archaeological research project. His field experience spans numerous excavations and surveys in Greece, France, and Spain, contributing expertise in GIS, photogrammetry, geophysical survey, spatial data management, and digital documentation. In addition, Quentin has been actively involved in teaching, student supervision, and conference organization, contributing to international events such as the GIS in Crete conference and the CAA 2025 session on digital fieldwork documentation in archaeology. So please, you can join us in welcoming Quentin Drillat, who will be sharing with us today his expertise on digital archaeology and spatial analysis in Mediterranean contexts. So Quentin, the floor is all yours.
Okay, can you hear me? Yes?
Yes, perfect. Yes.
So, good afternoon, everyone, and thank you very much for this invitation to speak in this lecture series on mapping the past. I'm really happy to be here online to share some elements of my research that was mainly conducted as a PhD researcher at Ghent University and now partly at the commercial archaeology company EVEHA International. So my work focuses on the long-term spatial organization of city-states in central Crete and how communities structured and negotiated their territories from late Minoan II to the Hellenistic period, but mainly across the first millennium BC. And today, I want to present the different stages of this research, from raw survey data to a spatial model of territorial borders. And I want to discuss how we can use legacy data, geospatial analysis, and modeling to rethink about the political geography of ancient Crete. So I want to show how we can go from fragmentary data, mainly survey data in that case, to the mapping of ancient borders through harmonization and spatial modeling. So the region I will speak about corresponds to the modern Iraqian prefecture in blue on the map here, which is located in the center of the island of Crete. And despite the fact that it is a modern spatial unit, it does have some geographic, topographic meaning because it's bounded north and south by the sea, of course, and limited to the west by the Pleurotis Range and to the east by the Lathisi Mountains, both culminating higher than 2,000 meters above sea level. And additionally, a third smaller mountain range, the Asterousia, is located next to the Libyan Sea, south of the area, and limited access to that sea from the land. So now the period we will focus on, so basically the first millennium BC correspond to the period of birth and development of the city-state organization after the end of the palatial organization in Crete. So after the Bronze Age, with large territorial states centered around palatial sites such as Knossos in central Crete, the area is reorganized in smaller local communities that progressively structured themselves into city-states over the first millennium BC. And actually, Crete and central Crete is particularly interesting to study because many small city-states appeared in a rather small area, creating an highly compartmentalized space within an already naturally compartmentalized space. So the big question is, how did this transformation reshape the landscape, and how we can reconstruct the borders and internal hierarchies of these small states. And to structure the research, I worked around a few key questions. So how can we harmonize and reuse legacy survey data that were collected with different methods? Which settlements acted as long-term central places? And I will come back to this definition later. Can we use cost-based modeling to reconstruct territorial borders? And finally, how did borderlands function economically and politically? And so the approach I have developed in my research is a modeling approach based on the use of spatial analysis in a GIS environment, because unfortunately almost no data is available on borders in central Crete. Only very fragmentary epigraphic data from the 2nd century BC, so for the very end of the period under study here, is available in central Crete for the site of Tilissos, and even more fragmentary for the site of Prianthos. So that's why modeling is necessary to define territories and to study borders in this area. So the first step was to combine into a single data set all the known settlements in the Iraqian prefecture that show at least one occupation during the periods we're focusing on. And what appears very clearly right from the start on that map is that the data set is very unevenly distributed. The density of site is extremely variable from one subregion to another. And this is not a reflection of ancient settlement patterns. Actually, it's not because some areas were less occupied. What we're seeing here is actually the result of the history of research in these areas. So some parts of the regions have been surveyed very intensively, while others are mostly known from local excavation, or in some cases even not studied systematically at all. And so if we look more closely at where the data comes from, so here I'm showing the distribution of sites by primary data provider, we can immediately see that a large part of the data sets come from survey projects. And these survey projects often focused on relatively small areas, but they did very intensively. And that gives the impression of densely occupied subregion within the study area, within the Iraqi prefecture. And on the other hand, areas that haven't been the subject of systematic surveys appears much less densely occupied in the datasets. But again, as I just said, it's not because they were less inhabited in antiquity, it's a direct consequence of how uneven the research coverage is across the region. And actually, in very densely occupied regions in the dataset, and in particular in the Galatas area, which is one of the densest zones in the entire datasets in terms of site distribution. We can see that I mean this area is very densely occupied because it was surveyed twice over the last 40 years, first by the Pediata project and later by the Galata survey project. And both surveys included the surroundings of the Galata site within their study area, which means that the same landscape was surveyed and walked twice. And this produced a very high number, of course, of recorded sediments. And what's particularly striking when you compare the two surveys is how often sediments appear in one data set, but not in the other, even though they are supposed to cover the same area. Yeah, so some sites recorded in the first project were not seen again in the second survey, and the other way around. And actually, this is the reflection of a very well-known phenomenon in survey archaeology, especially for rural sites, which is sometimes called the traffic light effect. Because these kinds of sites, the small rural sites, tend to appear and disappear depending on surface visibility, vegetation cover, or field condition. So what we are seeing here is not really a contradiction. It does not mean that one survey results are more reliable than the others, but it's a reflection on how survey conditions shape what we're able to detect and to map as survey archaeologists. And in other cases, both survey recorded settlements in very close proximity to each other, sometimes just a few dozen meters apart, but not exactly at the same spot. And because of that, they were recorded as different sites, even though they might probably reflect the same ancient settlement. Indeed, the traffic light effect that I just mentioned doesn't just happen between surveys. It can also happen within the limit of a single ancient settlement. And that brings us to an important distinction, I think, the difference between what we call an archaeological site and what was in ancient times an ancient settlement. And in my view, what is recorded as an archaeological site, and especially in survey projects, is more like a visibility window on an ancient settlement. So a fragment of a larger archaeological deposit. And so in some cases, what we have are like multiple archaeological sites that reflects that are just different windows on the same ancient settlement. And this seems to happen especially in areas covered by very intensive surveys, or even more by multiple surveys, like in the Galatas area in central Crete, where we see many sites recorded in very close relation to each other. And so that clustering probably doesn't reflect a cluster of really separate farmsteads or hamlets. It's more likely the same settlement being recorded multiple times under different conditions or survey units. And so I propose to address this by matching together these nearby sites in the database, and by recalculating the extent of the underlying settlements. And this prevent issues such as like statistical biases in the analysis that could be induced by the double record of the same settlements. But so we need a systematic way to deal with those matching sites. And the rule I have used was the following. So when 2 or more sites, maybe sometimes 3 or 4, are located within 100 meters of each other, and also share overlapping chronologies, they can be treated as reflecting the same ancient settlement. And this has important consequences actually in the dataset, because once we recombine those matching entries, we can recalculate the spatial extent of the settlements. And since site hierarchy, and what I mean by hierarchy is whether it is a town, a village, a hamlet, or a farmstead, it's strongly tied to the site size in the dataset, as in most regional survey in Crete, actually. So that means that we can update settlement ranks in the dataset. And so this matching process allows us to update the archaeological maps for each period. So on the maps, you can see here, whenever a site is surrounded by a black square, it means that its hierarchical rank has been reassessed after matching 2 or more archaeological sites. So the matching of archaeological sites is useful for 2 main reasons, to recap. So first, it helps to avoid duplicate recordings. So we're not counting the same settlement multiple times just because it was recorded under different entries. And second, it gives us a better estimate of site size, which allow us to update the classification, and so to improve the archaeological maps. And it's also allow us for each site to follow its hierarchical changes over time, so to reconstruct its evolutionary trajectory. And I will speak more about evolutionary trajectories later. But now that we have dealt with the inconsistencies and redundancies in the dataset, we can move on to the next step in the process. The goal being to model, to map territorial borders around main settlements. But before to start with the modeling of territories, we should make sure that this approach is somehow meaningful. I mean, we should make sure that it does not give purely theoretical results that do not correspond to ancient reality. And as I said, almost no historical evidence of borders are known in the Iranian prefecture. But we can move slightly east to the city-state of Lato to confront modeling to epigraphic data available on the border of that city-state. Indeed, the borders of Lato in the Hellenistic period are very well known from the epigraphic documentation. And they have been already studied by multiple researchers who already proposed restitutions of the Latvian borders. So it enabled to develop and to improve and to test our models. So the methodologies that I have used is based on Least-Cost Site Catchments, which is a cost-based methodology which calculates for every point of space the closest central place in terms of energy cost to travel to that place. So it's basically a cost-based version of the Thyssen polygons. And as every cost-based method, the choice of the cost function, so the way to calculate the cost, is crucial. And so with the known borders of Lato, it was possible to test several cost functions against previous restitution. And in the case of Lato, if we apply Least-Cost Site Catchment around only independent city-states of the Hellenistic period, the results are not satisfying, actually, and they are quite far from the restitution based on epigraphic data. Because to be performant, this modeling approach has been applied to model territories not only around independent city-states, but also around secondary centers that were in the archaic period also independent cities, and also with the port of Lato at Camara included as a secondary center. And with these small model territories, it was possible to assemble those spatial units, those spatial tiers, to produce the total extent of the city-state territory in a quite satisfying way. And so this suggests that when a city-state took control of another, the entire territory of the latter was integrating into the city-state. And so it seems that borders of in the 2nd century BC follow the borders that were already delimited around independent polities in the previous period, and especially in the archaic period. And so in the area of Lato, these secondary centers were rather easy to select because the area is very well known archaeologically, and because previous independent city-states from the archaic period are well identified, and of course they structured the territorial organization at some point. But unfortunately, if we go back to Central Crete, the case of the Hierarchian prefecture is a bit more complex because, as we said, the data is very heterogeneous, and especially in the Pediada area here, it is rather difficult to select central places among the multiple sites known from extensive surveys. And so to detect those more important settlements, so the ones that acted as stable central places, just as the independent archaic cities around Lato, we can build a classification of settlements based on their evolutionary trajectory. And what I call evolutionary trajectory is basically the successive hierarchical ranks that a settlement can take over its history. So here in a 4-category classification, farmstead, hamlet, village, or city, and with their evolutionary trajectory, we can classify, we can make a typology of settlements based on their entire evolutionary history, using state sequence analysis and optimal matching techniques. And that's what I did in the articles that I mentioned here. But here we can use a slightly more straightforward classification, because we only need to extract from the database the settlement that structured durably space, so the stable central places. And to do so, we can attribute values to the different classes from 1 to 4, and then sum the successive values for each settlement. And the sites the higher in this classification are considered stable enough over the first millennium to structure durably space. And as a result, territories of these stable central places can be modeled around these sites, and their border considered as stable borders over time. But one correction is necessary, because arbors that mostly developed during the Hellenistic period present low values in this classification. But we have seen with the case study of Lato that port cities were necessary to be included to properly model the territories of city-states. So here, as we did with Camara, we also included as central places the arbors north and south of the study area. So now, with the same method as in the case study of Lato, so Least-Cost Site Catchment Analysis, we can model territories, and these territories, again, there are only spatial units, spatial tiles, that can be assembled to produce the total extent of polities, of city-states territories. So they are not necessarily political limits over the entire first million BC, but at least they are limits of subregions, of districts, let's say, that seems to be very stable over time. And actually, one of these small territories around Tilissos had already been studied by Evangelos Kyriakidis, who showed that the limits of the small city-state of Tilissos correspond to the limits of the Bronze Age territorial unit as well, but also of the limits of the modern municipality. So this seems to confirm the stability of these small-scale spatial units over a very long period of time. So we have territorial units, 32 to be precise. And so we have the borders around them. And these borders, because of the way they have been modeled around stable central places, seems to be valid in a long-term perspective. So now, I will not speak today about the evolution of the territorial possessions of emerging city-states. So I will not describe how these spatial tiles were assembled following conquest over the course of the first millennium. But I would rather like now to study, to discuss borderlands. So that is to say, the areas that are next to borderlines. And to delimit these borderlands, we need double definitions. So first, based on an epigraphic document that mentions specific rules for lands in a zone of about 2 kilometers around the borderlines, we can define the border zones of 2 kilometers around the model borders as a first definition of borderlands. But with this simple definition, it appears that in some cases, and especially in that area, it appears that central places are located within the borderlands, which is, of course, not very satisfying, because borderland must be, of course, close to borderlines, but also in marginal areas. And especially a marginal area is an area away from central places, so outside of the central area that is next to central places. And here, to define central areas against marginal areas, I again used a cost-based analysis with a limit where the cost distance from central places equals the value of the standard deviation of the cost surface raster. And so to make the final delimitation of borderlands, we can combine zones that are in marginal areas and located less than 2 kilometers away from borderlines. and it appears to fit much better what we want to define as borderland, what we want to study as borderlands that are supposed to be, of course, close to borderlines, but also in marginal areas. And these borderlands, as you can see, mostly correspond to mountainous areas, including the eastern part of the Psilorítis and the western part of the Lathiti Mountains, and almost entirely the Asterousia to the south, and also some smaller relief in the center of the study area. But okay, let's see how the occupation of borderlands evolved over the course of the first million BC to better understand the use of these borderlands. So in central Crete, the settlement density smoothly increased from the proto-geometric to the Hellenistic period, driven by an increasing occupation of central areas. But in borderlands, occupation is rather stable, except for the Archaic period, when an important increase in the occupation of the borderland is visible. But as you can see, this trend is not durable, because settlement density is in borderlands is low again in the classical and Hellenistic periods. And when we look at settlement categories, it appears that this archaic explosion in borderlands occupation is linked mainly with one type of settlement that really expanded during that period, which is farmsteads, and also villages, but in a much smaller extent. And so from this observation of settlement patterns, we can try to move on to try to understand land uses in borderlands. And actually, density of farmsteads suggests a link quite strong between borderlands and cultivation in the archaic periods. And actually, it even appears that 80% of the settlements in borderlands are located in low slope areas, so under 13 degrees in gray on the map, while these low slope areas correspond to only 45% of the borderlands. So we have a clear preference for low slope area to install settlements in the archaic period, and of course these low slope areas are quite favorable for cultivation. So it was certainly the main economic activities of these settlements, and by extension of borderlands in the archaic period. So we have probably cultivation practices in the archaic period in borderlands, but what about the following classical Hellenistic period, where we have seen a drastic change? Well, it seems from the multiple treaties available in the epigraphic documentation, including between Hierapytna and Prianthos in central Crete, that new concerns appear regarding pastoralism at that time. And especially pastoralism appears to become the main activity in borderlands in the Hellenistic period. Of course, it was not a new practice. Pastoralism is very well documented from the Bronze Age, but it seems to be a new climax in the development of pastoralism in Crete, this Hellenistic period. But the treaties we have not only illustrate the predominance of pastoralism in mountainous areas in central Crete, but they also highlight cooperation practices between different city-states. Indeed, the different city-states agreed on sharing borderlands by giving grazing rights to foreign shepherds, either for occasional grazing or for long-term seasonal moving. So it seems that in the Hellenistic period, the borderland became an area of connection, of cooperation between polities. But actually, cooperation practices in borderlands are also attested outside of the economic sphere, of course, and especially in their religious life, but for whole periods, not only for the classical Hellenistic, by the presence of extra-urban sanctuaries exactly on the borderlines, and so on borderlands. And these extra-urban sanctuaries were often used by citizens of multiple city-states. And by the way, the location of these sanctuaries that are known to be related to borderlines straighten the modeling by confirming the location of some borders. So we have a change in borderland use that appeared from the study of settlement patterns within borderlands, but we haven't yet discussed the reason of that changes. So the first answer might be climate change, actually, because we know that in the late classical Hellenistic period, the winters are more severe and more snowy, resulting in the abandonment of agriculture in most of the plains among the mountains of Ida and in the other Cretan mountains. So this statement from Theophrastus is also confirmed by a few environmental studies conducted in Central Crete, actually. And so the climate was, in the classical Hellenistic periods, not as favorable as it was in previous periods. And so cultivation was probably not anymore the main economic activity of borderlands, as we already said. But in order to conclude my presentation, I would like to think again about the driving factors that controlled the changes in borderland use, because we have been able to see a change in the main agricultural practice in borderlands. In the archaic period, we have a peak of occupation, especially with many farmsteads. That suggests that these areas were largely cultivated. And in the following classical Hellenistic periods, we have depopulation that is observed, and combined with the epigraphic documentation, it suggests that pastoralism became the most important activity in borderlands. But this economic change also induces a change in the conception of borderlands, as we said, from private areas controlled carefully by polities to areas of connections. And so the first factor that we mentioned as a driving factor of this change is climate change. Indeed, the classical and Hellenistic periods present less optimal condition for cultivation. But climate change can not explain alone all the observed changes, because paleoenvironmental records in Central Crete does not suggest any drastic change in the environmental setting in the archaic period. And in the archaic period, after gradual decrease in borderland occupation from the proto-geometric to the underutilizing, we have observed a drastic change in borderland occupation, which suggests different practices and so perhaps different socio-political organization. And actually, archaic period is also the period of the final consolidation of the city-state organization in Crete. So the development of settlements away from city centers within borderlands could also reflect a will of city-states to better control their territories at that time. So we have here a combination of environmental and socio-political parameters at play. And I hope that I have been able to illustrate how we can try to identify them using geospatial analysis and by analyzing settlement data in their landscape. Thank you for your attention.
Thank you. Thank you, Quentin. Very interesting. Very interesting. First of all, I mean, call everyone. If you have any questions, please put them in the Q&A. And so I will start, or unless if my colleagues, Yanis and Meliana, have any questions. But I mean, until we're ready, first of all, the idea of borderlands, the boundaries as dynamic and multidimensional spaces, rather than fixed boundaries as we have in mind, is a very interesting topic. And to tell you the truth, my main research field, which is Northern Greece, I basically come to the same conclusion. So I found it very interesting. I will start with a methodological question. Okay, so if I understand right, the coast surface, building the coast surface, played a very important role in, reconstructing territories. My question is, as someone who is using this method, what do you think are the key methodological challenges? I understand the advantages, but what do you think are the key methodological challenges in applying the coast surfaces? Where this thing can go wrong in building a model? I don't know if you understand what I'm saying, but
yeah,
I'm playing the devil's advocate here.
Actually, that's something that I try to discuss there. So of course, the cost function that you will select will have a strong impact on the results. But as I said, in that case, because the case of Lato is very interesting because we know quite well the borders because we have epigraphic data. We also have some archaeological sites that are most probably related to borders with forts and extra-urban sanctuaries, and so we can the borders have already been delimited, so we can challenge the modeling practices against these results. And yeah, what seems to me the most important thing is that if you only apply this to using as sources the independent polities, it was not working very well for the Hellenistic period. So that's why I needed to use small spatial units around small central places. In that case, that was archaic, previously independent cities from the archaic period. And this applying this, it seems to work quite well. But that's why I think it's very important to try to always try to to compare our results to some evidence that we might have. Of course, archaeological data on borders is quite rare, unfortunately. But yeah, I think in some cases it's possible to challenge our model and then we can apply them to other places. But yeah, definitely, I think the main aspect is to think about the selection of the centers that we will use for the modeling.
Yes, exactly. Yanni, you have a thank you.
Thank you very much for this presentation. It was very stimulating, in fact. My question is this, that the way I understood this presentation is that the foundation of this whole study is the hierarchy of the sites. And this leads to how the borderlines are formed. So my question is, okay, we understand towns, but what about the rest of the sites? What are the criteria for delimiting these farmsteads, these villages, these hamlets? Where's the borderline between these sets, these terms?
Yeah, actually, I reused the classification that was made in the surveys that produce the data because since I've reused data from survey projects mainly, I reused the classification, which is actually purely based on site size. Of course, it has limitations, as we all know. But since in some cases it was the only criteria that we had, the site size was in some cases in some cases almost the only indication that we have about the site. I have reused exactly the same classification method, and so it was applied for each period when we had enough information. But yeah, basically, I tried to homogenize the classification among all the datasets, because for some survey project, the limits are not set exactly at the same size. For instance, I don't know, 1 hectare to distinguish a village to a city or whatever. And so I try to homogenize everything using the last published survey project, which is the Galatas project in the Heraclian prefecture. So I reuse the same criteria as in the Galatas survey publication.
Okay, I'm asking because as far as I understand, this is more or less a universal typology. I mean, we also find these terms in other studies as well. So what I find interesting is whether there is a certain differentiation concerning, let's say, Crete. What about the local and how we can find a typology that suits better to local standards than the terminology that we use globally in archaeology?
I'm not sure to understand. You mean you wonder whether we could make a typology fitting better for this?
If there is a chance for something like that, to create typology that seems more unique to Crete rather than a typology that could be used in other places as well. Does the archaeological record allows something like that? Does it allow?
Yeah, I think it's quite difficult, but of course, to improve the classification of sediments, it would be interesting to have access to archaeological material as well, just to know better about the function of sediments. Because especially for small sites, we always say that they are farmsteads, which is the standard classification for small rural sites. But of course, they could have other activities. So yeah, definitely using archaeological material is the way, I think, to improve our classification. But yeah, that's not something that I have done so far, definitely.
Thank you.
Okay, Biljana, if you have a question?
Yeah, I want to ask about the evidence that you found, because you talked about the switch from agricultural to pastoral. Are there any archaeozoological studies done? Did you use any of that type of evidence? Or
No, I didn't, to be honest. I know that some studies on that specific topic are done for the site of Azoria, definitely, but within Central Crete, I don't know many evidence. I have no clues about archaeological records that have been studied. So no, I haven't really used archaeozoological.
I mean, I know it's mostly JS, but it would be an interesting aspect to see. Maybe if the theory is backed up by that type of evidence.
Yeah, sure, definitely.
Yeah, so yeah. Should I read the question list on the chat?
Yeah. Okay. Yeah. You read it. I'm going to read it.
Anything you want?
Okay, go on.
So we have a question from Vera Antoniadis, who says, "Is a great presentation. He really liked your take on sites and units and surveys, but he has a question. Since you mentioned epigraphic evidence and sanctuaries, especially in the Hellenistic period, is there a particular case study where spatial and archaeological evidence as well as epigraphic evidence are tested together? It's not really a different question from what Vasilis asked. I'm just curious."
Sorry, I'm reading it again. Yeah, actually, it's the case study I presented on NATO. I think answers Viron's question, because this is where I try to test together epigraphic evidence and from previous studies and spatial modeling. I'm not sure that I have understood well the question.
If I get it right, I think he's Viron, and I'm really sorry, but Viron cannot use his microphone to explain it better. And my greeting is also to Viron. Is actually if there are this kind of graphic evidence that basically validate your model. If we have a case like
yes, like for Central Crete, for instance. Actually in Central Crete, like as I said, a study was previously done on the case study of Telesos. I haven't shown it here, but like we can compare the results that I have here and the results based on epigraphic evidence, which don't fit that well. But the reason is that it is on the border of the study area, and as in any model, we have edge effect, which prevents the result to be very good in the edge of the study area. So for the Telesos case study, it's not working very well, I have to say. We have some evidence, as we said, for Prianthos. The epigraphic data is very limited, but it seems to fit pretty well, actually, with what is described in the Prianthos epigraphic data. But it's so limited that it's not very interesting to compare directly, because we cannot draw lines. I mean, we cannot draw border lines based on the epigraphic evidence around Prianthos, unfortunately, as it was done at Lato.
Yes. Well, I mean, Viron says thank you, and with the chance of Viron intervention, I have to say what you guys did in Crete with the conference, and of course previous studies on the GIS of Crete by Apostolos Saris and others. I mean, Crete now is one of the places in Greek archaeology that's very well studied in spatial terms. Okay, so I was thinking that the model we're building here and the models that you also presented in your conference with Viron, that you co-organized with Viron. I mean, if we manage to expand this thing in other areas of Greece and then compare models of site catchment, of boundaries, of land use, this would be a very interesting next step in GIS archaeology in Greece. So it's just an idea that I had now that you're, discussing that, because I had the chance to read some of the papers in your conference and I found it really interesting. So it's a model of approach, spatial approach that we can extrapolate in other areas of Greece. Yeah.
Well, actually, like this way also to model space, to model territorial units. It's exactly what Sylvian Fachard did as well for the Athic DIMS, and it worked pretty well because he was able to compare his results, his modeling results with the ORI, and it seems to work quite well. So indeed, that would be very interesting to expand it in other places of the Greek world.
Yes, yes, great, thank you. So if you don't have any other questions, and I don't see anyone, let me check in Q&A. No, Quentin, thank you. It was extremely interesting. Not only this, I mean, we will be in touch because the model you presented today fits perfectly with data we have and we are working with. So it was, I wish you every success in your PhD, and from what I heard, it will be definitely successful. So thank you very much for taking part in this series of lectures, and to everyone that you had the stamina to attend this very hot evening, at least in Greece. And I welcome you all for the next year, for the next round of lectures, next circle of lectures. We will announce everything in our webpage, which if Meliana has the courtesy to write down the our address, and we will continue with the new rounds. I remind you that for this year we had Emer Farinetti, we had John Bindliff, who made us, the favor to come and present his research. And of course, Quentin, which is a young researcher, who is an expert in geospatial techniques, and we're very thankful for that. So we wish you all a very good summer, and we hopefully see you again from October or November next year. So thank you, Quentin, and you can watch everything also in our YouTube channel. Thank you very much.
Thank you, everyone. Bye.